today is something called a set. A set is a collection of objects, whereas a list is a sequence of objects. And let me just illustrate what I mean by collection and the reason I don't say sequence. When I print this set, which you can see I'm doing here on line 4, you can see that the items are out of order. That is, they're not in the order in which I placed them. You can look at the order and try to decide why Python may have reordered these items this way, but I defy you to actually find a logical reason for Python to put a D before an A, for example, or a Z before a C. They're not in alphabetical order. In fact, they're not in any order that really matters to us. That's because a set is not designed to hold on to order. You may remember with a list, we talked about a list as having a sequence, having its own order. And the sequence, because we call it a sequence, it's important to understand that a list will retain its order, and a set will not. So if I do the exact same thing with a list sequence, and I print that list, we're going to find that the set does not retain its order. The list does retain its order as long as I don't have a syntax error. Now, why doesn't a set keep its order? Well, a set is designed for membership tests. A membership test is one in which we look to see if an item is in the set. Now, we just saw that you can do that with a list, and that is true, you can. But with a set, it's going to be a little more efficient. Why is a membership test, for example, if we were, and I wanted you to see here that the output here is ordered, whereas the output here is not, and a list will retain its order. Why is a membership test, for example, if Z in X? Why is a membership test important with a set, even though it's possible with a list? Well, a set is actually ordered in a specific way, and if it is if we do some sort of membership test, the order of the set has sort of been pre-sorted in a way. For example, if we ask Python to check to see if the value Z is in the set X, it's going to check the first item, then the second item, or we might imagine that it would check the first item and then the second item and maybe find it in the second item, but that if we asked to look for D, it might check the first, the second, the third, the fourth, and finally at the very end find out that D is in it. But that's actually not how it works with a set. In fact, a set uses a special internal sorting algorithm to make it possible to check for membership quite quickly. And if you can imagine how our set might have 10,000, 20,000, 50,000, even 1,000,000 items, and we might be doing a membership test, that is this item in that set? We might be doing multiple membership tests within a giant set of items. You can imagine how inefficient that would be if we had to start at the beginning and then read each item until we found the item we were looking for, or maybe if the item's not even there, it would have to go through every single item in the set. Well, the way a set is ordered, the way it's kind of what we see as out of order, that special order is meaningful to Python. And Python will use it to do a very quick lookup of whether an item is in the set. I can't go into the specifics because I don't know them, and also because they're not really important to us. It doesn't really matter to us why a set has an out of order, or what the order is in an out of order set, but it is important to understand that the set is sorted the way it is, as we see in some sort of indiscernible order, because that's going to help the Python find an item within that set. The other thing that I want you to understand about a set is something that you'll see notated here if I were to add some duplicate items to the set and then print that resulting set. Now, as you can see, the duplicates were completely ignored in our set. Python saw that those items were already in the set and just discarded them. Again, why would we want our set to discard duplicates and show us only unique items? Well, remember, the primary purpose for a set is to check for membership. That's how a set works. That's what a set is for. So duplicate values are meaningless if we're checking for membership, right? If a value is in there twice and our overriding question is this item in that set? Then duplicates are meaningless. We don't want them. In fact, we don't want them at all. So a set can be used for a number of things. One of them, membership tests. Another, if you have a bunch of repeating data, but you want to see a unique set of items within that repeating data, you can use a set. Just pile the items into the set and let the set do its work of eliminating duplicates. In fact, we can do that here with additional items added to the set. I also want to show you how we can add items to the set. I'll add some unique items and then I'll add some repeating items. And we can see again that Python will take the new ones, it'll add the new items, but it will discard any duplicate items because a set always contains only unique items in no particular order that's meaningful to us.